So we're going to start with this warm-up about atoms and elements. And it's just to see what you know before getting started, what you think you might know. And then what are some questions you have about atoms, or even what do you know that you don't know, right? So like, I don't know if atoms fill up the outer space. Like, I don't know, right? So what do you know about atoms and elements? What do you think you know about atoms and elements? What are some questions you have about atoms and elements? Now that you've got that done, we're just going to refresh your mind about what atoms are. So matter is something that we talk about in science a lot. So matter, that's just stuff, right?
This interruption, Ms. Berenberg, please call the main office. Ms. Berenberg, please call the main office.
All right.
Thank you.
So matter is just stuff, right? So empty space can sometimes be filled with matter. Like this room may feel like empty space. The room that you're in may feel like empty space, but when I breathe in, I'm breathing atoms into my chest, right? So these atoms take up space and they have mass. Now, don't get me wrong. In outer space, that is a vacuum. So that just means that this distance between the atoms is really, really far. When in this class, like there's like probably like a million atoms more. There's more than a million atoms between, in my little sphere here, my parcel. So all matter is made of atoms that we know of. There is this stuff called dark matter in the universe that makes up, there's more dark matter than there is matter, but we don't know what it's made of. And we don't really know why it's there. It's just kind of there. It's a mystery right now. And atoms are the building blocks of matter. They're the building blocks of everything. They're the building blocks of you. They're the building blocks of me. I think there's 1 trillion atoms in the human eye. So that just gives you a perspective on how small these things really are. Okay? So, what is an atom? This is like kind of the classic image of an atom. This is not really what atoms look like, but it's kind of how you can think of it. Just to give you some more perspective, this middle here would be like super, super small. These lines don't exist, and these are electrons, which aren't, they are particles, but they're more probability waves than they are particles, which just means that like electrons exist, we just don't know where they are until we look for them. And then once we find them, they're not there anymore. So electrons exist, they're just hard to pin down. That's the general idea. Okay, so in the middle here, just like the middle of a cell is called the nucleus, the middle of an atom is also called the nucleus. We have these positive particles. Positive with P, proton, positive, proton is a positive particle. Around them are these other non-charged, no charge neutron, because they are neutral. Neutral in a war means it's a country that doesn't want to choose sides. Doesn't want to be for or against. It just wants nothing to do with it. So that's neutrons, and they're friends with the protons. They're buddies. They weigh just about the same amount. They hang out in the nucleus, and the neutrons keep the protons calm. Protons don't like being around other protons. They don't. So the neutrons are there to kind of like be like, hey, everyone, relax. Let's all just get together and have some fun. Okay? So the outside is the electron. This is the negative charge. And electrons do make up electricity through wires. And you can think about it. We can't reach into the middle of an atom and pull out a proton as easy as we could take from the outer part of an atom an electron and put it in a wire and produce an electrical charge. So that's the general idea. Protons, neutrons, they're on the inside. Electrons are on the outside. A proton, P for positive. Neutron is neutral, which means it has no charge. And then an electron is negative. Okay? So that's the general idea. And we call this electron area an electron cloud. We're going to get into this again later, but this first layer of electrons can only hold 2. So that's the inner area, and then the outer is going to be the this can only hold 8. So we call them shells. First shell holds 2, the second shell can hold up to 8 electrons. All right, so now we need to talk about some technical terms. We're going to be using the term atom, and we're going to be using the term element, all right? So to give a basic explanation, elements are the language of atoms and molecules. Elements are the name given to atoms depending on the amount of protons they have. So the amount of protons an atom has determines the characteristics of an atom. And not just all the characteristics, but the basic characteristics. Main idea. Here's gold. Gold has 79 protons in it. If anything has 79 protons in it, doesn't matter how many neutrons, doesn't matter how many electrons, it is gold. Okay? That is gold. 79 protons. Okay? So this is how I like to think about it. These are all dogs, right? Poodles, pit bulls, Labradors. They're all in the category of dogs, right? But these are different breeds of dogs, right? Still dogs, all dogs, but different breeds of dogs. And we can tell them apart, right? The Labrador, pit bull, poodle, they look different, but we know they're all dogs. Just like how we know that these are all atoms, right? They're all atoms. They got protons and neutrons in their nucleuses. Well, this one just has a proton. And they've got electrons in their outer shells. But because they have different numbers of protons, 6 protons, carbon, 8 protons, oxygen, 1 proton is hydrogen, because they have different protons, they are different elements. They're all atoms, but they're different elements. And the element name is carbon, oxygen, hydrogen, lithium, helium, iron, gold, silver. All these things are going to be different atoms, or different elements, different elements. And these are all the elements that exist, and in some cases, like some of these, don't exist, or are just way too unstable to exist for longer than like microseconds or nanoseconds. But you should recognize some of these. Hydrogen's on the top left, helium is on the right side there, super stable elements here, and then super active elements even more so as we go down. All right, but these are our periodic table of elements, and you can see where's gold. Here's gold. Gold has the number 79 in the top. I don't know if you remember, I was just talking about how gold has 79 protons. So this number up at the top is the amount of protons. That's what makes it gold. Carbon, like we just saw, has 6 protons. That's what makes it carbon. Oxygen has 8 protons. That's what makes it oxygen. If we add another proton, it becomes fluorine. All right? Not really possible, though. Okay, so reading the periodic table, we are almost all set. This is how the periodic table is going to look. Something similar to this, right? So this is an element, or similar to this. So you can see there's a number, a letter, a name, and then another number. A number, a letter, a name, another number. This is the atomic number. That's the thing that makes this element what it is. In this case, carbon. It has 6 protons. But this atomic weight, I don't know if you remember, I was talking about how protons and neutrons are buddies, so they have a similar weight. But electrons on the outer part, they have a weight, but it is super insignificant compared to the protons and electrons. That would be like me standing on a scale, right, measuring my mass or measuring my weight, and then someone handing me a feather, like a bird feather, right? So like that's not going to impact the overall weight of me. Just like how the electron is not going to impact the atomic weight. It's just really the protons and the neutrons. So this is important here. The atomic number on the top left is the amount of protons. The element symbol, or in this case the C, or the AU for gold, this C is going to be just, its Latin or its Greek name, right? And the element name, of course, is going to be our English version of that. So like gold is AU, that's the symbol, but we call it gold. It doesn't have those letters in it, but the Latin or the Greek word is going to have an A and a U in it. You don't have to know that. Anyway, this is the important part, the atomic weight. The atomic weight is the mass of the most stable or the most common elements or atoms that exist, okay? So, a proton has an atomic weight of 1, which is nice and easy. A neutron has an atomic weight of 1. So this is how I figure this out. The overall weight of all of the protons and neutrons in a carbon element is 12. We know that there are 6 protons in carbon. A proton has a weight of 1. So to figure out the amount of neutrons that are in a stable carbon, we just subtract the atomic weight from the atomic number, or we subtract the amount of protons from the weight of the protons plus the neutrons. Okay? Oops. So this should make sense. Okay, so in this case, so these 6 protons have a weight of 6, and if we subtract the atomic number from the atomic weight, the atomic number taken away from the atomic weight, we can determine the amount of neutrons in the stable carbon atom. So let's try to figure out the amount of neutrons in a stable nitrogen. There are 7 protons in nitrogen. The mass of the protons and the neutrons is 14. So if we have 7 protons and 7 of the 14 is being made up of protons, that means we have to do 14 minus 7. That gives us 7 neutrons, all right? And what's the opposite of a proton? Protons are positive, so the opposite of a proton is an electron. And atoms like to have a balance between those, or really, really close to a balance between those, all right? If they aren't balanced, that means it's an ion, which just means it has a charge to it, okay? We don't have to really know that for this class. But if they ask you for the amount of protons, protons is this number. If they ask you for the amount of neutrons, it's this number minus this number. And if they ask you for this class, the amount of electrons, it's just going to balance the amount of protons. So you'll see the first few elements, or the first elements on the periodic table here, like all the way up to around chlorine, for the most part. Around chlorine, they have a kind of balance, right? So like 32 minus 16 is 16. 30 minus 15 is 15. 28 minus 14 is 14. They have a balance between the amount of protons, neutrons, and electrons. But then once we get to something like mercury, which has 80 protons, but a atomic mass or an atomic weight of 200, this is going to have 80 protons, and to keep those protons all stable and together, because they don't like being around each other, 200 minus 80 is 120 neutrons. So mercury needs 120 neutrons in order to keep those 80 protons stable for mercury. Okay, so it's not always going to be the same numbers. We have to do the math. That's the main idea.